All right, folks, let's continue with learning about antiderivatives and integration in calculus. You've already learned how to identify the indefinite integral of an expression. It's basically the opposite of the derivative. And so now what I'm going to do is we're going to talk about, I'm going to show you how to do it probably goes by a lot of names, but one of the things I call it is identifying the specific antiderivative. Now, when I say specific antiderivative, this is what I mean. Let's say we want to know what the antiderivative of 7x to the third power is, right? And you say, oh, well, that's a polynomial, Mr. Ryan, so I know what to do. I'm going to add 1 to the exponent, so it's going to become x to the fourth. And then I'm going to divide the 7 by 4. So I'm going to have 7 over 4. And I say, very good. And then I'm going to put on a plus c. So the antiderivative is 7 over 4 times x to the fourth plus c. I say, very good. You've been practicing your antiderivatives, so you know how to do that. So you're in pretty good shape so far. But now what I'm going to say is this is not a specific expression. This plus c makes it indefinite. And that's what we talked about in one of the last videos, is that is an indefinite integral. Well, what we want to do in the specific antiderivative is, one of the things that we discussed is the reason we put the plus c on is because we don't know if there was a constant and what that constant was. Well, with finding the specific antiderivative, these kinds of problems, you're given some kind of initial condition. Initial condition. Usually, you're given an x and a y point that this graph passes through on the coordinate plane so that you're able to solve for the plus c. So basically, what we're doing with the specific antiderivative is we are solving for the c, solving for the value of c. So, solve for the value of c. Okay? So what I'm going to do right now is I'm going to put a problem up on the board and we're going to work it through. All right, so here's a question. It says the function f of x is a specific antiderivative of the expression 8x cubed minus 1, such that f of 3 is 197, which means if the x value is 3, the output value is 197. If you were to plug a 3 into the function f of x, the answer would be 197. And the question is saying, what is f of x? Well, we know that f of x is an antiderivative of 8x cubed minus 1, so why don't we start by getting the antiderivative of 8x cubed minus 1. Why don't you pause the video and go ahead and do the antiderivative of this. All right, so hopefully what you did here is we've got a power rule here and we've got a constant rule. So the antiderivative of this first piece is the power goes up by 1, so it's 4. Then we divide 8 by the new power, 4. So x to the fourth, 8 divided by 4 is 2. So the antiderivative of this is 2x to the fourth power. Minus. And then the antiderivative of 1 with respect to x is 1x, or just x. So minus x. Now let's stop for a second, and I'm going to show you how I know that this is correct. If we now do the derivative of 2x to the fourth, if y was equal to 2x to the fourth minus x, what would the derivative be? What would y prime be? Well, 4 times 2 is 8, x, 4 minus 1 is 3, and the derivative of minus x is just minus 1. Look at that. The derivative is 8x cubed minus 1, which is what we started with. So we must have done it correctly. Okay, good. So, antiderivative, 2x to the fourth minus x, plus c. There we go. Here's our indefinite integral. This would be the function f of x. So f of x is equal to 2x to the fourth minus x plus c. However, it's not really a function with this plus c here. What we're going to try and do right now is we're going to solve for c. We're going to solve for c using this information. This is called the initial condition. And so basically what we're going to do here is, let me write out a procedure. Step 1, find the antiderivative, or the indefinite integral, let's say that. Find the indefinite integral of the given expression. That's step one. The next thing you're going to do, step two, plug the x value. Plug the x value from the initial condition, plug the x value from the initial condition into each x in the indefinite integral. So, here's our indefinite integral, 2x to the fourth minus x plus c. And in all the x's, there's one right here and there's one right here. We're going to put the x value from the initial condition. Well, the x value from the initial condition is 3. So we're going to put a 3 here and a 3 here. So I'm going to rewrite it as 2 times 3 to the fourth power minus 3 plus c. There we go. That's step 2. Step 3, set the modified, well, let's just say that, set it. Let's just say that. What you just did. Set step 2 equal to the output value from the initial condition. All right, what is the output value from the initial condition? Well, this is the input, the x. The output is 197. So we're going to take this expression we just did and we're going to say equals 197. Step 4, okay, let me come over here. Solve for c. That's all you're going to do in step 4. Just solve for c. Look, we only have one letter now. So 3 to the fourth power, that's 81. 81 times 2, that's 100 and, hang on a second, 81, that's 162. 162, right? Okay, good. Now, minus 3 plus c is equal to 197. 162 minus 3, well, that's 159. Plus c is equal to 197. Subtract 159 from both sides. And now c is equal to 60, since 30, 38. Is that right? 60, 79, yep, 38. So c is equal to 38. And so now, last step, substitute the value for c into the indefinite integral, definite integral. So watch this. We're going to go back to the indefinite integral. Here's the integral. Here's the indefinite integral right here. We're going to rewrite this. This is f of x. So now f of x is equal to 2x to the fourth minus x. And instead of plus c, we're going to put plus 38. And now look, the question says, what is f of x? There's our answer right there. There's f of x. 2x to the fourth minus x plus 38. And you can check to make sure that's the right answer by plugging a 3 in for x and making sure that your answer is 197, okay? This is the procedure by which you find the specific antiderivative. Let's do a couple more examples. All right, here's one for you. It says the function g of x is a specific antiderivative of 2 to the x power times the natural log of 2, such that g of 4 is equal to 11. What is g of x? All right, well, let's follow our procedure. Step 1, find the indefinite integral of the given expression. Here's the given expression. The indefinite integral of 2 to the x times the natural log of 2 is 2 to the x power plus c. That's the antiderivative, okay, by one of our rules, the rule of the derivative rule of exponential expressions. And now, step 2, plug the x value from the initial condition, which is 4, into each x in the indefinite integral. Well, we only have one x, so we're going to go 2 to the 4th power plus c. Step 3, set what you just did in step 2 equal to the output value from the initial condition. So equals, the output value is 11. And now solve for c. Well, 2 to the 4th power, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power, we got 16 plus c is equal to 11. Subtract 16 from both sides, and we get c is equal to negative 5. Last step, substitute the value for c, which is negative 5, into the indefinite integral. The indefinite integral is 2 to the x plus c. So now we're going to say g of x is equal to 2 to the x power minus 5. And that is our answer. Okay, that's pretty quick, right? Let's do another one. All right, for this one, you are going to need a calculator. Now, when you get a calculator, because we're dealing with a trigonometric function, in calculus, we always deal in radians, not in degrees. So if you see the scientific calculator that I have, if you see down here, it says DEG, that means degrees. Okay, what I have to do is I have to hit the DRG button, that means degrees, radians, gradients, and then I go over to radians and press enter, and then down here it says rad. That means I'm now in radian mode. And in radian mode, I can do this problem. So it says the function h of x is a specific antiderivative of sine of x, such that h of 6 is equal to 20. What is h of x? Well, step 1 says find the indefinite integral of the given expression. The given expression is sine of x, so I'm going to do the indefinite integral, or the antiderivative of sine of x. The antiderivative of sine of x is negative cosine of x plus c. Negative cosine of x plus c. Okay? And now, step 2, plug the x value from the initial condition, that's a 6, into each x in the indefinite integral. Well, I only have one x, so I'm going to put a 6 in for x here. So I get negative cosine of 6 plus c. And then step 3 says set that equal to the output value from the initial condition. So equals, the output value is 20. And then solve for c. Well, in order to solve for c, I need to know what negative cosine of 6 is. So that's why I got the calculator. So I'm just going to do cosine of 6, and that is 0.9602. 0.9602. I'll stop there. And then it's negative. So I got negative 0.9602 plus c is equal to 20. Now, if I add 0.9602 to both sides, all right, I get c is equal to, this is going to cancel, 20.9602. And now, last step, substitute the c back into the indefinite integral, and h of x is equal to negative cosine of x plus 20.9602 approximately, and there is my final answer. And so this is how we solve for or identify the specific antiderivative, because we're solving for the value of c. And if you can do this with any function for pretty much any input output value, and any function that you can take the antiderivative of. Okay, so get lots of practice doing this, and you should be in really good shape. And I'll see you in class.